sort of where some of you are. So we start Unit 7 today. Trigonometry is the unit. Day 1 today is right triangle trigonometry. So eventually we can do any triangle, but today we're going to worry about only right triangles. And specifically when we talk about triangles and angles, we mean sine, cosine, and tangent. So you've seen it before. How much do you remember? We'll see as we go. Let me start by drawing a couple of right triangles. I mean, you know what they look like. We will try to trick you a little bit based on how we draw them. Like that's the easy one, but sometimes we'll draw them so that the right angle is in what we think of as like a weird spot, like that. It's still a right triangle because it has a right angle. But some people, they sort of get tricked into thinking that the right angle is always the one at the bottom left. No, it's whatever one has the little box there. All right, 2 Roman numerals today. First one is the 6 circular functions. You're familiar with 3 of them, sine, cosine, and tangent. Circular functions that's kind of the weird name for it. It might have been better to call it the 6 trig ratios. And you can combine any set of those words, like you can call them circular ratios or trig functions, or circular functions or trig ratios. So, pick one from column 1 and one from column 2, and we'll know what you're talking about. I will probably call them trig ratios most of the time, maybe trig functions. All right, let's start with a right triangle. And let's label one of the angles theta. Are you familiar with theta? Have you seen that variable before?
No.
It's a Greek letter. It's just a variable. A lot of times for angles we use the Greek letters. So we'll call that theta. And then I want to label my sides relative to that angle. And you may not know what that means, but as soon as I say one of them, you'll probably know what the others are. So across from theta, opposite. Because it's on the opposite side of the triangle from the theta. Opposite. Do you remember the fancy word for next to? Adjacent. And the fancy word for the side across from the right angle? Hypotenuse. And then you might remember that we use those letters, the first letter of their names, frequently. O, A, and H. Opposite, adjacent, hypotenuse. What's that? SOHCAHTOA. So that's what we start with. So the sine of the angle is SOHCAHTOA, opposite over hypotenuse. Opposite over hypotenuse. And then here's how this thing works. It doesn't matter how big the triangle is. So I hope this doesn't get too confusing, but if we make a little bit bigger triangle, the opposite is bigger and the hypotenuse is bigger, but that ratio, O over H, would be the same. So the sine of the angle is opposite over hypotenuse. It doesn't matter if the opposite is 1 inch long or 1 mile long. The ratio is going to be the same. And that's what makes these 6 ratios so important or work so well, is that it doesn't matter how big or how small the triangle is, the ratios stay the same. All right, how about cosine of theta? Remember what that one is? Adjacent over hypotenuse. And tangent of theta? Opposite over adjacent. So this you're familiar with because someone said it a minute ago. So ka toa. Just be careful with the ka. Some people just rattle it off too quick. So ko toa and end up with O over H for cosine, but that's what sine is. So ka toa. Another favorite from some students and teachers. Some old hippie caught another hippie tripping on acid. So if you like the more edgier version of the little saying, most people just remember SOHCAHTOA, and you're fine with that. That's the three you know, but there's three other ones that are reciprocals, that are flips of these. So these might be new. CSC of theta, that's cosecant. Cosecant is just the flip, so H over O. And then SEC, secant, is the flip of cosine, H over A. And you know what the last one is? We got sine and cosine, secant and cosecant, tangent and cotangent is A over O, cotangent. Now this one doesn't have a mnemonic device. Like every year someone wants to go like Cho Sha Cow or something, which I guess is fine and isn't wrong. It's just nobody does that though, because what's more important is to know who they're partnered with. So know SOHCAHTOA and then know who the reciprocal partner is. So you don't really memorize the ratios as much as you memorize the partners. And if you know the partner, then you just flip the ratio. Because we're going to need the partner thing quite frequently next semester. So don't worry about Cho Sha Cow. Just know that cosecant goes with sine, secant goes with cosine, cotangent goes with tangent. And so if you need one of those, you think about the original and you flip it over. That's by far the easiest way to work these problems. All right, let's write the 6 trig ratios for theta in this triangle. Six trig ratios for theta in that triangle. Well, I need to tell you where theta is. Let's put theta at the top. Again, we try to move around what the triangle looks like and where theta is, so that you don't get in the habit of thinking that the opposite is the one on the bottom. It's not the bottom one, it's the one opposite the angle. We need some side lengths. So let's go 2 for this side and square root of 3 for that side. Before I get started writing ratios, I'm missing something. Hypotenuse and right triangle geometry experts. What could I use to find the missing hypotenuse? Pythagorean theorem. A squared plus b squared equals c squared. 2 squared plus square root of 3 squared equals c squared. 4 plus 3 is 7. So my missing side is square root of 7. Oops, c squared equals 7. So c is the square root of 7. And then even before I start writing ratios, let's label the sides. That way it'll make writing the ratios easier. So which side is opposite of theta? Square root of 3. So let's label that O. You can write out the whole word if you want, but I'm just going to put an O there. Which side is adjacent to the angle? 2. Good. That's a little bit tricky because I guess there's sort of two sides adjacent, but the hypotenuse has to be the hypotenuse, so the other side is the adjacent. I would suggest labeling all your triangles with opposite, adjacent, and hypotenuse because it makes the rest of the problem really easy rather than you each time trying to remember who goes where. Just label them, and then it becomes hopefully pretty easy. Sine of theta. And by the way, I'm always going to put them in this order. That way that'll help me remember what they are and where things go. So I'm always going to lay it out like sine, cosine, tangent. And leave a little space because we are going to have to do something with those. And then cosecant, secant, cotangent. Let's see, sine is opposite over hypotenuse. Opposite over hypotenuse is square root of 3 over square root of 7. But something about that we don't like. You know what it is? Square root in the bottom. And how do we fix the square root in the bottom? Multiply top and bottom by that square root. So we get square root of 21 over 7. So it took a little bit of a fix there. Cosine, adjacent over hypotenuse. So 2 over square root of 7. Again, it requires a fix. An easy fix though. 2 root 7 over 7. Tangent is opposite over adjacent. Opposite over adjacent. 3 over 2. Do we need to fix that one? No, we're good with that one. That one does not have a square root in the bottom, so we're good. And as usual, I'm showing sort of all the steps that one could possibly show. I would expect most of you probably won't show all of those steps. Some of you will write the O and A and H. Others of you will skip that step. Some will try to skip all the way to the end and fix it in your head too. That's a little bit more dangerous, but as always, show what you need to show. Cosecant. Okay, I don't memorize what cosecant is other than I know it's the flip of sine. So if I flip sine, I've got two options here. I could flip the final answer or I could flip the original answer. And either one is going to get me there, but I think it's going to be easier if I flip the original. So if I flip the final, I'm going to have square root of 21 in the bottom. That's going to be a little more complicated. I think I want to flip the original. So square root of 7 over square root of 3. That still needs to be fixed, but it's easier to fix square root of 3 than square root of 21. Square root of 21 over 3. Secant, kind of the same thing. Go back and I could flip the final, but it would probably be better to flip the original. Square root of 7 over 2. And I don't even need to fix that one, so that's nice. Cotangent, I don't have an option. I'll flip tangent and then fix it. 2 root 3 over 3. So when it says write the 6 trig ratios, that's pretty easy. You got to know SOHCAHTOA. You got to know who the partners are. You got to be able to label who's opposite, adjacent, and hypotenuse. Might have to find a missing side, but pretty straightforward.
You're just allowed to, for the cosecants, you're allowed to just flip them upside down if you want.
You're allowed to flip what?
Well, Well, because you said when you were doing all three of them, you were flipping them.
right?
The original. You're allowed to do that, I guess.
Yes, because root 3 over root 7 is the same thing as root 21 over 7. So I could flip either one. But it's usually easier to flip the original. Because if you flip this one, you're going to end up with 7 over root 21, and then you're going to have to fix it with root 21. 7 root 21 over 21, which reduces to root 21 over 3. So you get the same thing, it's just a little bit longer path to get there. So again, don't memorize the cosecant, secant, cotangent in terms of their ratio. Memorize who they're partners with. That will be a much bigger help in the long run. Right, example 2 is with calculator. So I'll hit pause so everybody can go grab your own calculator or grab mine. Sine of 67. Although we do need to be careful, 67, that's in degrees. So make sure go to mode and make sure you're in degrees because it's probably defaulted to radians. Especially if you have a calculator that a calculus student used, they would be in radians most likely. So change it to degrees or make sure it's in degrees, and then all you got to do is hit sine of 67. Today's pretty easy. Today's like getting some building blocks so that we can do some more stuff with them. 0.921. Let's do 3 decimals because that's what the AP test does. So we'll just kind of get in the habit of that early on. Okay, but secant of 27 is a little harder because there's not a secant button on the calculator. The only buttons you got are sine, cosine, and tangent. But who is secant partners with? Cosine. And when I say partners, I even gave the hint with my finger motion here. Let's don't say inverses. Let's use another fancy math word. It means flip it over. Reciprocals. So I don't have a secant button, but it's 1 over the cosine of 27. So it's still not hard to do in the calculator, but you do have to know how to handle secant since there's not a secant button. I guess you could use the fraction bar, but for 1 so easy, I'm just going to do 1 divided by cosine of 27. 1.122. And why don't you try the cotangent of 58? So that's 1 over the tangent of 58, 0.625. Pretty easy stuff there. Any questions on that? Again, you got to know who the partners are. That's the big thing for today. Secant, cosine, cosecant, sine, tangent, and cotangent. Roman numeral 2. Start to use this stuff by solving right triangles. Solving right triangles is sort of the fancy way that math teachers ask you to find all missing info. Meaning sides and angles. So rather than on each problem saying find side A and angle B and angle C, we just say solve the right triangle. And that means find all the missing stuff. There's 3 tools to use. 2 of them you're very familiar with. 1 of them you're less familiar with. In fact, we used one of them already. So we'll start with that one. A squared plus b squared equals c squared. So there's your sort of your formula that relates all the sides of a right triangle. I guess we should emphasize these are only for right triangles. And that's all you're going to have today. But we have to be careful later on. If it's not a right triangle, then you can't use a squared plus b squared equals c squared. So that tells you about the sides. How about the angles? The angles of any triangle. Do you remember from geometry long ago? They all add up to 180. So the angles add to 180 degrees. So that's your angles. Your angles tool. And then lastly, you have SOHCAHTOA. SOHCAHTOA combines angles and sides. Right? Because sine, cosine, tangent of an angle equals some ratio of sides. So that's the one that... and by the way, you almost will always have to use all 3 of these, one each time. All right, so let's solve the triangle. It looks like this. So triangle ABC, angle C is 37, angle B is the right angle, and side C equals 12. Okay, side C is one of the sort of hidden tricks that's going on here. You have to know that side C is across from angle C. So that will mess people up. They'll find all the right things, but they'll have them labeled wrong because the B's are across from each other, the A's are across from each other, and the C's are across from each other. But I mean, it's not hard, but you do have to consider that when you're labeling things. All right, so we're missing angle A, missing side A, and missing side B. Which one do you propose that we find first?
Angle A.
I like that answer. How can we find angle A?
Yeah, you just add 90 and 37.
Yep.
And subtract it from 180.
180 minus 90 minus 37. You will have a calculator, so if your integer math in your head is a little rusty, 90 minus 37 is 53. So angle A is 53 degrees. Some people like to label the triangle as they go, helps them keep up with what they know and what they don't know. Other people just want to box it as they go. I'm fine either way. I say I'm fine either way. I'm going to label the triangle. That way I can keep up with what I know and what I'm still looking for. All right, I need A and B, sides A and B. A squared plus, well, that's even wrong too because the sides are mixed up. But it wouldn't help anyway because I don't know 2 of the sides. So I can say A squared plus C squared equals B squared. By the way, I intentionally messed up the letters to force us to think about things. But that doesn't help because I don't know either A or B. So I can't use that yet. Which means that I need to use either SO or CA or TOA to figure out a missing side. When it comes to using SOHCAHTOA, identify the angle first, and then pick which ratio you want to use. Because if you got to identify the angle, because that sets who's opposite, adjacent, and hypotenuse. We have options here. We could use 53 or 37. Either would be fine to use, but I'm going to argue that one of them is a little bit better choice. Why 37? You're right. Why 37 rather than 53? It's smaller? Fair. I would pick 37 because it was given. I know it's right. I know 53 is right too, but just in case I messed up something in figuring out 53, we should probably use original angles as much as possible. So 37 will be our angle that we're talking about. That will set who's opposite and who's adjacent. Opposite, adjacent, hypotenuse.
So the angle that they give you is always going to be theta?
You should probably set the angle they give you, call that theta. Yeah. You can do it with 53, but what if you made a mistake figuring out 53? Then that error sort of continues through the whole problem. So you should use the original whenever you can. Okay, so now we got to figure out which ratio to use. If I use sine of the angle, that would be opposite over hypotenuse. Opposite and hypotenuse. Okay, that might work because I don't know the hypotenuse. Cosine of the angle would be adjacent over hypotenuse, but I don't know either one. Right? Maybe some people will start doing this. So I know opposite, I don't know hypotenuse, I don't know adjacent, I don't know hypotenuse. So I definitely can't use cosine because, I can write it. Cosine of 37 equals A over B, but that doesn't help me because I don't know A or B. So if I got two question marks, I got to throw that one out. I can't use that one. Tangent. See, I know the opposite. I don't know the adjacent. So this is the process of picking the ratio. Pick the ratio where you know at least one of the sides. Don't pick one where you don't know either side. So I have a choice here. I can use sine or I can use tangent. Anyone got a preference? It does not matter at all. Sine it is, so we'll use sine. So sine of the angle, sine of 37. Always sine of the angle. Don't ever, some people, they memorize SOHCAHTOA and then they write sine of opposite over hypotenuse. It's not what that means. Sine of the angle equals opposite over hypotenuse. So 12 over B. Now I've got some algebra to work with here. Let's multiply both sides by B. And then let's divide by sine of 37. And that will tell me what B is. 12 divided by sine 37. 19.94. So now I know B. I'm not going to label it on the triangle because my picture is a little crowded as it is. But if you want to label it, you can. That way you keep up with what you know and what you don't. Only one thing left, and that's that's side A. What do you want to do to find side A? There's two options. You could use tangent, so you could write tangent of 37 equals B over A. Equals 12 over A. But you could also do something else. I know two of the sides,
Not that many.
so you can do a squared plus b squared equals c squared. Although, I keep saying that wrong because I labeled the triangle weird. A squared plus 12 squared equals hypotenuse squared. So hypotenuse squared minus 12 squared. Kind of a common mistake is to forget to square root it, but hopefully you'd be paying attention enough to realize that 253 seems like a really big number for this problem. 15.925. All right, let's do one more problem. And mix up the letters to make us think about things a little bit. And let's just do the old 3, 4, 5 right triangle. But now I don't know any angles. Well, I guess I know angle B, that's 90. But I don't know angle A and angle C. So let's think through our tools here. A squared plus B squared equals C squared, that's true. But that's already worked, so that doesn't help. The angles add to 180. I mean, that's true too, but I don't know angle A or angle C, so that doesn't really help either. So that leaves me with SO and CA and TOA. And I don't know any of the angles. So which angle do you want to find? We got to identify it so that we can label opposite, adjacent, and hypotenuse. So let's pick the angle that we're talking about. And it doesn't matter, we just need to pick one and all be on the same page here. You want to do A or C? A it is. So let's talk about angle A. That sets who's opposite, who's adjacent, and who's hypotenuse. And the nice thing is, I know all the sides, so I can use any of the trig ratios that I like. Let's see, last time we used sine, so let's use a different one this time, just for the heck of it. Let's do tangent. So tangent of angle A. Okay, this is a little different. I don't know angle A, but I do know opposite over adjacent. Tangent of A is 4/3. So do you remember how to get your calculator to go backwards? Like, how do I find an angle whose tangent is 4/3? What's that? Inverse tangent. So angle A is the inverse tangent of 4/3. It means find me an angle whose tangent is 4/3. So second tangent, inverse tangent, 4/3, 53.13 degrees, so that's angle A. Now I could sort of restart the problem and find angle C the same way, or this is where labeling helps. I now see that I've got two of my three angles. So what can I do to find angle C? Yeah, 180 minus the other two. .87. All right, I need to do one more. So if the cosecant CSC of theta equals 1.7, how do I figure out what theta is? Cosecant of theta equals 1.7. I mean, I'd like to do inverse cosecant, but I don't have that option on the calculator. So, who is cosecant related to? Sine, and they're related by being reciprocals. So I'm going to say that the sine of theta, what would the sine of theta be? 1 over 1.17. So now I can do inverse sine, 1 over 1.7, 36.03. All right. Notes probably took longer than it'll take many of you to do the worksheet today. A lot of background stuff, but I don't think it's too difficult.